So yeah, I'm Fabio. Please notice this part. There's a diacritic there. So if you want to make fun of me on Twitter, you be sure to use it. So basically, yeah, I'm Fabio. This is my usual self. I don't know what I'm looking at. I'm sorry. I work at Yield, and I have lots of fun every day writing JavaScript. And we are hiring, by the way. You should join our awesome crew. What the fuck? So yeah, what language is this? Does anyone know? Does anyone recognize, these symbols and stuff, right? I was hoping you guys would say PHP, because yeah, this is JavaScript. When you remove the semicolons, it becomes obvious. Okay, and people are making fun of me on Telegram. Cool. What about this one? Exactly. So this actually compiles. Yeah, it's C now. You have to broaden your horizons. I'm going to teach you guys how to squint hard enough so that you look at JavaScript and it's actually C and it's actually faster. In some cases. In most cases, it doesn't work. It crashes on me. I don't know why. And yeah. Anyways. We're going to talk to you about JSCPP, which is pronounced JSCPP. This transpiles JavaScript to C++. It may be faster. Last week, it was actually crashing my computer because it was allocating lots of memory, and I haven't plugged in the garbage collector yet. It has a lot of stuff. I've managed to somehow implement closures based on a paper I found from the 60s about Lisp and stuff. Yeah. I'm sorry, guys. But why would anyone? Why? I mean, what are you doing, Fabio? I don't know. So I decided to write some afterthoughts in this slide so that I could somehow justify my madness. But yeah. You can teach people stuff, and you can run on embedded systems without running V8. Boring stuff. Yeah, let's just transpile stuff, right? So how does this project do C++? You just have to write int before every variable. So you just set out var and func and write int instead, right? Nope. I've actually had to recruit some EPIC help from an EPIC project, which knows what types my variables are when I'm transpiling stuff. This code does not compile right now, so please ignore it. This is only an example of how stuff can be incredibly hard. So you have a var and you change the type because it was initially a number. Now it's a string. What the hell, right? What does this function return now? And what type is this variable? It's two types, right? It changes. Yeah, so I've recruited this EPIC project. Tern.js may be in some of your text editors. And Hassie can't breathe. Okay. So how does this thing work? Somehow it's written in CoffeeScript and works. So it parses the JavaScript with Acorn. Then I use estraverse.replace because I'm lazy. I don't want to make my own recursive function. And some of these transforms will return some C instead of returning an AST node. So estraverse.replace is a function that takes a JavaScript abstract syntax tree, which is a representation of your code, which contains your identifiers, your statements, your expressions, your binary expressions, and your functions and stuff. And it's beautiful. And you kind of use this function, and it takes an AST node and it returns another one, which is why it's called replace. In some ways, in some code paths, I will return some actual C code because I found an arbitrary JavaScript injection in the code for ES code gen. So I'm exploiting a vulnerability in Xcode gen to do this. So this is a very simplified example. It's actually much simpler than this because it's CoffeeScript, right? So I do replace. I forgot to return stuff. Then replace takes an object. There's a leave function which is called when ES traverse is leaving a function. I check the node type, and in this case we are reading a function. The return time, I just ask tern for everything. It knows. I don't know. Then I transform the body. I turn the parameters one by one. The function parameters, like function AB, return A plus B. I get A, I get B, and I ask the types for those in other places. So I map them. Function parameters are function parameters with parentheses, and then JavaScript joins this into a string with commas and stuff, which is beautiful. So I just have to return like int, main, the parentheses and the parameters, and then the function body, which includes the curly braces. And this is actually a big deal, because if it weren't for the curly braces that this would generate, I wouldn't have had the patience to even start the project. I couldn't bring myself to wrap stuff in curly braces. It's boring, right? Anyways, so there's more. Variables can be strings, ints, and stuff, and they can be objects as well. I haven't implemented arrays. So I stole an idea from V8, which is hidden classes. So when V8 finds a variable of yours or a constructor a function of yours that it knows that's going to return such and such object, in an overly simplified way of saying things, it creates a class that has all the fields that this object will have, which makes property access much faster. So tern knows. So I asked tern, tern, maybe if I want to make a hidden class, would you please tell me what properties will I need to generate and what types they are? So you take this var x, which is going to be an object, but thus far it's a boring empty object, right? Then you assign a couple properties. But tern looks at this and it says, oh, this is not an empty object. This is going to be an object that has a y and a z. It's very smart. So I write this in the output. I make some fake classes. It has the parameters. Yeah. And this is the basis of closures as well. Closures are also classes, which is weird. Haven't gotten used to it. So yeah, if you guys want to dive deep into madness, you can check out the GitHub repo, for which I forgot to link in this presentation. And oh, it's demo time already. I wasn't ready. Okay, let's show you some stuff. Oh yeah, this heart on my shell stands for love. Can you guys see and stuff? All right. So this is the actual repo. It works on my machine. So I can compile some stuff like demo1.js. This looks interesting. What is this? Who put this here? Let's look at it. Yeah. I'm going to console log some stuff. Boring stuff, right? Yeah, so this code is extremely simple. I'm going to exemplify that a very simple fake class. So, yeah. This is what it generates. Let's look at demo1.cpp. Okay. So this is the fake class, which I promised you guys. So you remember there was a y that was a number and then a string that was something like hello C++ or something. I have a simple constructor. This is not needed. Whatever. And I wrap stuff into a function called int main, which is mandatory to have. It's not mandatory to have the arguments for it. If you guys know C and find this weird. And then I console.log. So let's compile this stuff, right? Compile and run demo1.js. No. Yeah, it says hello CPP -1. So what kind of stuff can we do here, right? I guess I have to show you guys how console log is implemented, just so I can bore the shit out of you, right? So you've noticed that I include some runtime thing. If I actually go and see it, that's it, yeah. You'll see that there's a class called console, which has a function called log, and this is how I implemented console log without transforming anything. So basically, I declare this console named console, and I just use it. Yeah, this is basically it. Has a function called log, takes a variable number of arguments, which is the most beautiful part of C++. It's the, I think it's in the C++ 11 spec. Anyways, beautiful stuff. So I promised an EPIC Fibonacci benchmark. So let's see one. So let's look at the code. It's recursive. It logs some stuff and it calculates Fibonacci in a way that I am not sure is the most efficient, but yeah. So let's transpile this thing, right? FIB 45.js to FIB 45.cpp. So fib45.cpp looks something like this. I have ruined the names of all functions because I am a lazy bastard. This is, insofar the C++ that is generated is objectively ugly, and this is not a bug. So let's compile it and run it and time it. So it generates some numbers on the Fibonacci sequence, which some of you might not know, but it's a very beautiful mathematical sequence, and I like it. And it's going to take some time, but not as much time as Node, of course. Because, yeah, not NPM, it would be even slower. So as you can see here, it took 0 minutes in C++ to do this, and took 14 seconds. You can run this to 15, but anyways, let's run this in Node. Of course, this is using a lot more memory. So I could actually tell you a story about that one time I was drunk and I did talk about the transpiler, but I won't. It's a work in progress, you see. So yeah, this is going to take all day. Sorry, guys. You can do it, Node. I believe in you. Is it done? Woo! I forgot to time it! So yeah, I could time it, but it's boring. Last time I timed it, it was like 45 seconds or something. But yeah, my computer is weird. Yeah, anyways, this is just the CPP transpile stuff. Pull requests are welcome. They can be in JavaScript, but they can only go in like a month from now because in implementing closures, I implemented some crashes. And they aren't bugs. They're just things that I'm going to do away with as future features, right? So yeah, right now the code is pretty unstable. I wanted to show you guys some more stuff, but it all crashed. So yeah, what is the future for this thing? I have no idea. But there's a very dumb project called dumb.js, which does the major workload of this, which is transpile JavaScript into simple JavaScript. So basically, I take a language which uses closures, and then I blurt out a language which doesn't need closures. So I create an object that can be callable and takes a closure. And this is how I can pass closures around. And this is also how you can waste memory. So I wish to implement lots of stuff, including constructors, this, arguments, generators, and also, I forgot. This is all going to happen in this dumb.js project. It's the most interesting of the two, because it can also be used to transpile to other stuff, for example, C, which you guys can try, right? And yeah, I am going to get garbage collection in this thing. I don't know if you guys know of a project called the Hans Bohm garbage collector. So I found it on the interwebs. Oh yeah, I was already in my browser. This is it. It might not load. Oh, okay. There we are. So yeah, this exists, and I want to plug it in, and this is how I am going to plug in the garbage collector into my project, making it something that looks a lot more like JavaScript. This is a very interesting project, which I absolutely recommend you guys to look at. So yeah, 42 seconds. So yeah, since none of you guys left at garbage collection, I'm going to implement this Friday. So yeah, anyone got any questions or anything?
Who's got questions? There we go.
What sort of stuff have you?
What sort of code have you transpiled so far, other than, simple examples?
I am completely unable of doing arrays, for example. There are major flaws and stuff I can't compile. But I can transpile lots of stuff. I'm currently working on implementing require, which I hope is going to be a thing like Browserify, where most modules in NPM are accidentally compatible with Browserify. I would like to use modules from NPM and write some C++, and the guys wouldn't have any idea, right? It would be very funny if I just took like modules like once, which are very simple, makes a function only be callable once, and transpile it and use it in C++ and do fast code. Yeah. Anyone else?
Why did you pick C++ as your target?
So I was looking at new stuff from C++, and actually, C++ is actually very close to my heart. It was my first language, which means I know nothing of it. And I looked at the new stuff from C++, and I was like, oh my god, you are beautiful. You have you have variadric function. No? Yeah, whatever. You guys got it. You now have an auto keyword. You can use auto as you use var in JavaScript, and it just figures out the type for you. And I was like, oh my god, this is beautiful. I have to write some C++. And I was like, oh, this looks a lot like JavaScript. So yeah, that's why. My future ambitions lie with C, actually. Because there's a very, very interesting project called TCC, which you guys might know. I haven't searched in a while because it's in my heart. Okay, it's called the Tiny C compiler. So it runs in memory, compiles C, and this is how I hope to implement eval and other stuff. This is a lot faster than GCC as well. And this is old. I mean, 2004? When was it? Like 10 years ago? 11? Oh, I can't even. All right.
Sorry, I have a question here.
Yeah.
Hey, how are you? So basically, I want to ask you about the assignment case, like when you have x equals 10, x equals string, right? So do you remember that case that you said that you couldn't handle?
I never got to try it, but...
Because my question is basically, it's been a long since I code like C on C++, but I think there is like something called union types that you can actually define, and probably that would do the trick. That's why I'm asking.
That's a very good idea. I was actually looking into using a box type, like create a class that says, oh, string or int, right? And then resolve it like Schrodinger's cat, and then throw an exception if it's wrong, right? But I will look into that, because I looked into that before and I forgot about it.
How do you handle events? Or is that on the map?
Next question. So events are undefined. I handle nothing right now. I have console log, recursion, closures, very, very basic stuff. And events and streams, I hope they can come later and join me in my quest of madness. So basically, I was also hoping to implement an event loop, which would be amazing. But that's not your question, because events can be synchronous, right? JavaScript.
Cool. Do we have any more questions?